In this lesson, we're looking at acid-base theory. So basically, we're going to take a look at how acids and bases behave both similarly and differently when they react and when they dissolve in water. So in this lesson, you're going to need a copy of this handout, Acid and Bases Theory. So the first thing we're going to look at is how acids and bases behave differently when they dissolve in water. So a base, when it dissolves in water, it dissociates. So what this means is that water pulls apart pre-existing ions of an anion compound. So dissociation is basically separating pre-existing ions. This is a lot different from what happens to an acid when it dissolves in water, because an acid ionizes. So ionization is when the water pulls apart the compound, but ions are formed from a neutral or nonpolar molecule. So basically, in ionization, we are making ions. This makes sense because a base is an ionic compound. It contains a metal and nonmetals, and basically it is that electrostatic attraction of those ions. So the water pulls it apart much like it would just any other ionic compound. The next thing we're going to look at is a comparison of our strong and weak acids. So what we know is that the strength of an acid depends on something called percent ionization, which is basically just the extent of which the acid is going to ionize, how much of the acid is going to be pulled apart and form ions in that aqueous solution. We know that a strong acid completely ionizes. And we also know that our weak acid will only partially ionize. So our strong acid completely ionizes, or to at least 90% in solution, where a weak acid only partially ionizes, usually only like 2%, but it's always less than 50%. So we're going to draw a little diagram to show this. If we have a strong acid here, and we're going to say that this dot is a hydrogen ion, and we're going to say that this is a nonmetal. In our solution, we have our acids, compounds looking like this, the hydrogen and a nonmetal bonded together in our solution. When the strong acid dissolves in water, it looks like this. Most of the hydrogens and the other nonmetal have broken apart, so they've almost completely ionized, except for this one piece right here. It's not 100%, but it's close. If we did the same thing for a weak acid, we would have only partial ionization, and it would look something like this. Only one of the compounds have broken apart. So an example of this weak acid would be our acetic acid. So the reason why you had hydrochloric acid have a much higher conductivity compared to our weak acid is because how conductive an acid is depends on its percent ionization. A strong acid has a really high percent ionization, which means it has a really high or strong conductivity. It made the light bulb really bright. Our weak acid, though, has a really low percent ionization. So it has a really low or weak conductivity. And the light bulb, when you checked this conductivity, was really dull. Okay. The last thing we're going to mention is that the corrosive property of acids, so what makes an acid really dangerous, is due to our hydrogen ion. So basically, the more a hydrogen ion is in solution, the more dangerous the acid is. This means that a really dilute, strong acid is more dangerous than a concentrated weak acid. Even though it's a less concentrated acid, it still has a higher percent ionization, and there's more hydrogen ion in the solution, making the acid more corrosive. So if we do a little summary to compare our strong and weak acids, it's right here. So they differ in their hydrogen ion concentration, their conductivity, their percent ionization. They also differ in pH. Strong acids have a very low pH and weak acids have a pH close to 7. We're going to discuss this reason in a different lesson. And they also have a different reaction time. Strong acids react very fast with metals and weak acids very slow. And also, we'll tuck in a couple examples of both types of acids here. So some strong acids are HCl, we have already talked about, sulfuric acid and nitric acid. And some weak acids are all our carbon-based acids. So bicarbonate and carbonic acid is another example. So because of the way these acids and bases behaved in water, this guy named Arrhenius came up with a theory. And basically he said that ionic compounds dissociate into cation and anions, and that's what makes a solution conductive. And we know that's true. He added that acids are hydrogen compounds that increase the hydrogen ion concentration of a solution. So something that looks like this. And he suggested that bases are ionic hydroxides that increase the hydroxide ion concentration in solution, so something like this. Now, it turns out that these definitions can't always be used to predict if a substance is an acid or a base. And so he had to come up with a revised definition, and this is the one we are more interested in. He came up with his new idea, and he said, in acidic solutions, the hydrogen ions are constantly in motion and colliding with water molecules. Since water is a polar molecule, the hydrogen ion ends up bonding really strongly to the water molecule if they become close in proximity. And when this happens, the hydrogen ion is said to become hydrated. So a hydrated proton is called the hydronium ion. And the hydronium ion has the formula H3O+. But because it's unlikely that hydrogen ions actually exist in a solution, he came up with yet another revised definition, and he says that acidic solutions form when a substance reacts with water to form a hydronium ion. So, for example, if we have hydrochloric acid and it's reacting with water, it's going to make a hydronium ion and a chloride ion as its products. Okay, so basically, Arrhenius says that acids form when a substance reacts with water to make a hydronium ion. Okay, it's just important to remember that a weak acid still fits this definition. They just produce less hydronium ions from the same volume of concentrated solution. Okay, so we still have to talk about strong and weak bases, but I'm going to leave you to use these pages in your textbook to fill in the blanks here. In our next lesson, we'll look at how pH value and a hydrogen ion concentration are related. But for now, to look at the strong and weak bases information. See you next time.